Provisioning a virtual machine is really only day one. Day two is everything that comes afterwards. Checking it, patching it, installing software, changing configuration, troubleshooting problems and generally keeping it running. In this video I want to show how IntelliconOps brings AI into those day two operations without simply giving an AI model uncontrolled access to a server. The idea is that I can describe what I want in normal English. IntelliconOps then turns that request into a proposed automation. I can see what it intends to do, review the generated Ansible, approve it, execute it through the IntelliconOps worker, and then see evidence of what actually happened. So the AI helps create the automation, but it doesn't just go away and make changes by itself. Before I submit the request, I want to quickly show automation knowledge. This is basically a library of approved guidance that helps the AI understand how I want particular types of work to be carried out. It uses a RAG style process. RAG stands for Retrieval Augmented Generation. That sounds more complicated than it really is, but IntelliconOps looks through the approved knowledge entries and finds the ones that are relevant to what I'm asking, as well as the cloud provider and operating system I'm working with. It then gives the most relevant information to the AI as additional context. A simple way of thinking about it is that we're putting the relevant pages of an approved operations manual beside the AI while it creates the proposal. In this example, I've got an entry covering VM inventory and system information. It tells the AI that if I want things like CPU, memory, disk, IP address and operating system information, there's already an approved way of collecting that information. It also tells it where the resulting file should be stored. The important point here is that automation knowledge provides guidance. It doesn't execute anything and it doesn't override the security controls in IntelliconOps. Now I'll go to one of the virtual machines that IntelliconOps is already managing. I don't need to tell the AI how to connect to the machine or start writing Ansible myself. IntelliconOps already knows which VM I'm looking at, which cloud it belongs to, which operating system it's running and how the platform can securely reach it. Credentials and private keys are not being sent to the AI. It's simply going to describe the outcome that I want. In this case I'm asking IntelliconOps to collect some useful information about this VM and save the results into a JSON inventory file. When I click generate, nothing runs on the VM. At this stage, IntelliconOps is only creating a proposal. The AI has interpreted my request and selected one of the actions that IntelliconOps supports. Rather than generating some arbitrary shell command, it has proposed the control VM statistics collection action. I can also see the Ansible it has generated. This is important because the automation isn't hidden behind the AI. I can actually see what is going to be run before I approve anything. For this request, the Ansible uses the standard facts collection capability to gather the approved system information. It isn't wandering around the machine reading home directories, credentials, command history or random files. It's collecting the operational facts needed for this particular report. For this request, success means that the suspected inventory file was actually created and stored correctly. Once I'm happy with the proposal, I can approve it. The approval applies to this particular version of the automation. I'm not giving the AI permanent permission to operate this machine. Now I can execute it. At this point, the work is passed to the IntelliconOps worker, which uses the platform's managed connection to reach the VM. My browser isn't opening an SSH session to the machine, and the AI isn't connected to the execution session. The AI helped create the proposal. IntelliconOps controls the execution. And now the operation has completed successfully. Here is the JSON file that I asked IntelliconOps to create. IntelliconOps has stored it privately and associated it with this operation and the user who requested it. Alongside the file I've got useful information such as when it was collected, which VM it came from, its size and its checksum. The checksum gives us a way of identifying exactly which version of the file was produced. I can now open the JSON and see the approved information that was collected from the VM. things like hostname, operating system, CPU, memory, IP addresses, network interfaces, disks and file system information. The file hasn't just been dumped into the temp folder on the VM or left somewhere in the public web directory. IntelliconOps manages the resulting artifact as part of the operation. The operation is also retained in IntelliconOps history. So this isn't like asking a chatbot a question and then losing the context afterwards. We have a record of the request, the generated plan, the Ansible, the approval, the execution, the verification and the resulting evidence. You'll also notice that IntelliconOps isn't offering to fix anything here. That's deliberate. This was a successful inventory request. There isn't actually a problem to fix. I don't want the AI inventing remediation just because it has been given an opportunity to do so. Remediation should only be suggested when a diagnostic operation has produced genuine evidence of a problem. There's another useful part of this workflow. If I've created an operation that I think will be useful again, I can save it as an IntelliconOps blueprint. That doesn't immediately turn it into published production automation. It creates a draft that I can review first. Inside Blueprint Studio, I can see where the blueprint came from. IntelliconOps keeps the original AI prompt as an audit record, while the generated Ansible code is treated separately as executable automation that can be reviewed, edited, validated and versioned before it runs. So the original request remains part of the history. I'm not rewriting the past as if I'd later changed the Ansible. If I want to change the automation, I create a new revision. The blueprint also keeps the rules around the controlled output file, so the reusable version still knows what kind of result it is allowed to produce and where that result belongs. Once I'm happy with it, I can validate the blueprint before publishing it. And once something is published, later changes go through another draft and validation process rather than silently modifying the working version. So in a single workflow, I've gone from a normal English request to an AI-generated proposal, to visible Ansible, to human approval, to controlled execution, and finally to a verified result with an audit trail. Automation knowledge helps the AI understand how I want the work carried out, and IntelliconOps decides what actions are actually allowed. I decide whether the automation should run, and the platform keeps the evidence of what happened afterwards. The successful operation can then become reusable, version-controlled automation through Blueprint Studio. For me, that's the important distinction with using AI for infrastructure operations. The aim isn't to hand production systems over to an AI. It's to use AI to make the engineer faster while keeping the review, security, approval and audit controls around the work. IntelliconOps is continuing to evolve as a multi-cloud operations and automation platform. If you'd like to discuss trialling IntelliconOps, exploring a potential use case, or seeing how it could fit into your own cloud and infrastructure environment, please do get in touch. IntelliconOps, intelligent cloud operations with automation and control built in.